All right, let's get started. Good afternoon, everyone. I hope you're not too sleepy after lunch. I think this topic is something that's super critical in the IoT world, so I think this will wake everyone up. I'm just here to, I'm Ankit Nevaskar. I'm part of the PDC product management group and Liveworx IoT. I focus on smart connected products. I'm just here to introduce Brian here. Brian is the CEO of Geisel software. Sorry. It's an IoT software development firm. They do some really cool stuff in medical devices and robotic space. I'll let him give the introduction of what they really do. But they've truly realized that although they do software development, security has been like the most important thing across all companies and clients. So they want to not just create products for clients that are innovative, but safe and secure. So join me in welcoming Brian Geisel.
Thanks, Ankit.
Thank you.
How's everybody doing today? Can everybody hear me okay? This is our first mic check. We checked the pointer, we checked the thing. Now we're checking the mic. All right, good. So how many in here like data and having data for things? 2 people. Okay, there we go. That's better. All right, good. So I like having data too. So let me get your data. So how many people in here are in the consumer or the business space in IoT, whether it's from you're building a device or your company works in producing them, helping companies that do produce them? Okay. All right, good. Good number. How about industrial IoT? I know we're talking a lot about industrial IoT. Okay. All right, awesome. How many wandered in from like South Boston thinking this was the aquarium? Okay. All right, not so many. All right, good, that's good. Or at least wouldn't admit it. You'll have chances to get out of here if you were looking for the aquarium as we go. So, as Ankit mentioned, we're a software development company. We're not a security company. That's not our thing or how we were founded. But really, we have to be a security company because we're building devices that are in a connected world. And so it's one of those things that for us is important because we've got to keep our client stuff secure. And so security has become an important thing, even though we don't look at ourselves or think of ourselves as a security company. If we're in this space, guess what? We all really are at some level. So you guys are all familiar with the Internet of Things then, and it's exciting to see what's happening in the Internet of Things and what's going forward. And I know if you came to this talk on IoT security, I'm probably preaching to the choir a little bit in terms of how important security is. But just like we all said we like data, I think it's important to look at data so that we know. And really, security right now is the #1 blocker of IoT adoption. This is whether we want to get more devices out to consumers or whether we want to get more devices in our factory so that we can do more things with those devices, improve our processes or improve the ROI, all those kinds of things. Security is the #1 blocker. And we all kind of know that that's been a big thing. But at least maybe it's getting better, unless we look at the data. So the data from respondents was from the previous year, 52% of respondents were more concerned about their data going forward than they were last year. So that's not particularly good that we're getting worse. It looked like we're starting to think about security, we're starting to look at it. So hey, we're getting better. That's good. Maybe, maybe not. The lovely thing with data, right, is we can transform it to be whatever we want it to be. So maybe 52% is because we're paying more attention to security. So maybe it's just we're learning about security, and so now we're concerned when we should have been concerned all the time. That'd be great, except we have more data. So my apologies, but it's been a while since I've been in any sort of school setting where I was graded on things. Does anybody have either kids in school or like you're in school? Like, what's an A now? Is it like 93% and above is an A or something? So that's some head nods. Okay. And a B is 83% and above or something? Is that true? C was like 70% and above. Now a D, 60% and above, at least we still passed. It's almost better than a C. Like now we're excited because at least we passed. But less than 60% we failed. So what would IoT security report card look like if we were to ask people, do you feel like you have a high level of trust in your data? Like A range, B range, B minus, C, okay, a few C's. D, how many think we like just barely passed? Okay, below D, okay. So the answer is 9%. 9% said we have a high trust and confidence in what's happening with our data. Whether this is a security cam that I bought and took into my home, whether this is devices that I'm installing in my factory, whatever, 9% of respondents said, yeah, we feel good about what's happening with our data. So it's a really big problem. Again, like I said, I realize I'm preaching to the choir a little bit here, but to see that number and realize 9% of people feel like they have a high level of trust with what's happening with their data, it really is a problem. One of the things that's different in IoT, and this is a little bit of what I want to talk about, is how it's different from what happened before it. If we're talking about consumers being on devices, on PCs, or those kinds of sort of what happened before IoT. Because part of, and it's interesting just as we're talking to people at this conference and stuff, seeing how much IoT has matured. And there's a little bit of this dichotomy where IoT's been around long enough, we have a lot of maturity in it, but every day we're getting new innovations. We're getting the devices smaller, we're getting devices to be able to last longer on a battery that's light enough that we can do something with it we couldn't do with it last week. We couldn't get a consumer to carry around this big thing, now we shrunk it down and we can and it makes sense. And so we've got so many innovations happening so quickly in IoT that it still keeps IoT a nascent market in the sense of there's brand new stuff coming in that we're solving these problems for still. So one of the things is that the thing, different than a person, the thing has to be protected. So people do lots of dumb things on the internet. We're all pretty familiar with this. The people, however, didn't get infected with a virus. Thus far, we have no transference from computer viruses to people. My grandmother, by the way, beat me to being a cyborg, which I was a little disappointed with. She has Parkinson's, and so they installed this thing actually in her brain that way improved her mobility and what she was able to do and all those kinds of things. But her and I both were quite surprised that she was the first one in the family to become a cyborg. So maybe eventually viruses can pass from the internet to people, and it's probably happening more and more. As a company, we do robotics and medical devices. So while I started with that as a joke, it's kind of real as medical devices are in your body. But the difference is they're still a thing, and that thing is now a thing that can be infected. The other thing, we're going to say thing a lot. Sorry, it's kind of a thing. So thanks for that courtesy laugh. I really appreciate that. So another thing that is different between having people and having things on the internet is that even if you made the world's most crappy password, you made it, it's inside your head or on a sticky note on your computer, whatever it is, but it's yours and you made it. When we do devices and we say a consumer device, for example, and we sell them, now anyone that goes to Home Depot and buys your consumer device has the keys because that device has to have the keys built in to get onto your web server, to get onto your, however it's communicating within your network. So by definition, you've given the keys to the attackers to get onto your network. I hope we don't have to talk about this anymore, but this, by the way, is why we can't have the same key on every device. Because as soon as anyone gets any of them, and by the way, gets them, you're handing it to them, then they've compromised your whole network. So obviously, I hope, we have to have different keys on all of our devices. And as we're handing these keys, even those individual keys, we're handing those directly to the bad actors. So if a device can get into my network that I made and do bad things, then so can someone else as soon as they have that device in hand. And then the other one is that now suddenly, because we don't have people as the end, there's a certain thing that just the human effect will solve for you. If you were on your PC and instead of getting a virus, someone replaced your operating system with a whole new operating system that did whatever they wanted, most people would probably notice that. Your IoT device won't necessarily notice. Your IoT device will just happily keep doing what it is, and unless you've installed things in your network to notice that that device went away, or to keep that device safe so that it's not doing that, those kinds of things, then we could be in trouble with that. So one of the things that protects us from this sense, and that we have to have a little bit of humility, I think, to do, is layering. And this is a security concept that's familiar to the IT space. We're doing this on our servers. We need to do it on our devices as well. And so just some example of things that we might have on layering. This is not a magic list of exactly how layering works. This is one of those things about the Internet of Things, is that all these devices are so different. Whatever the problem is that you're solving is different than the problem the next guy's solving, which means your device is different than the device that person's using, that company's using. And because of those differences in the devices, we had a bunch of discussions last night over at whatever the hotel was, from this conference that went over the hotel, right? And we had a bunch of conversations. And some of the people who were maybe not in IoT were asking all these questions about IoT, and they were like, well, how do you do this? And as we're trying to explain, we're like, well, it's different with different devices. Like if you have this one, then it might, and they were like, well, how do you just solve this problem? Well, it depends on the space that you're in. It depends on what you're doing, the battery life or whatever. So, you guys know what's the similarity between daytime television advertisements and answers in the Internet of Things? Every other one is depends. So, again, thank you. I appreciate you guys are on board with the courtesy laugh thing today. So, it really does. Every device is different, and it's one of the things that's created an issue with security in IoT, because there's not a one-size-fits-all solution. There are costs. So what if I can strap this thing onto my solution? Well, if we're in super low cost, maybe that's not an option for us. So each situation has a slightly different piece. The principles are the same, but the things that we're doing are going to be different. So an example here, we have physical security. Let's say maybe in the case of a device in a factory, maybe the physical security is locks on the factory and all our devices are in the factory. Okay, that's great, but I have to have these things on the internet so that they can push data up to a server where I can process the data. So now suddenly there's another attack vector besides physical. I can get access into the things. So, okay, I create a device firewall. So now I'm blocking things out of the firewall. And now no one can get in because I have a firewall and I'm secure. Except I've got to have some way open to let my data get in and out. And so I've got to have things communicating, and somewhere maybe I have, say it's a medical device, and I have physicians connecting to get the information about patients. And so there's a portal where physicians can connect. And so what if I compromise the username and password of one of those physicians? And so now we have secure credentials, and we have signature on the device. So the device should be verifying that you are in fact the server that's allowed to talk to me. And the server should be verifying that you are in fact the device I think you are talking to me. are you guys familiar with man-in-the-middle attacks? Okay, few people. So a man-in-the-middle is basically where there's a man who's in the middle. So say I have a server on one side and I have a device on the other side, and they're communicating. Man in the middle is someone steps in between those and pretends to be the server to the device and or pretends to be the device to the server. And this could happen in all sorts of contexts. But in this context, let's say I'm pushing firmware out to my device and there's man in the middle. This man in the middle that pushes firmware to the device can now, like I said earlier, put an entirely different operating system on the device. They could replace all the code that's on that device and turn that device into whatever they want. And we saw this a couple of years ago with Mirai, with the botnet that took down large chunks of the internet with a distributed denial of service attack that was launched on everyone's devices. So any device that they were able to penetrate into, they penetrated into, and then they were able to use all those devices to target actually some security personnel and target their stuff and try to bring it down through a distributed denial service attack. Who was the attacker? The attacker was people who made cameras for people to, security cameras at home or any of those sorts of things that were on the internet that got infiltrated. Suddenly, your device that you built to solve a problem suddenly is the problem. So, and then I was kind of surprised that it took the bad actors this long to come up with it. Then they decided, wait, why are we trying to take down the internet when we can use all of your devices to mine bitcoins for me? So then that was the next version of it. And then the next guy made one called BrickerBot, which just turns your device into a brick so that no one else could do bad things with it. So sort of the Robin Hood of killing your device. So now let's say somebody gets username and password into your system. And again, this is one of those places where we have to understand that devices are going to get compromised. It's going to happen. Every week in the news, there's a new report about either some startup that just had data unprotected laying around on the internet. That's our data, by the way. Thank you. That they just left on the internet. And it's not uncommon. It's been MySpace. All right, Snickers. Okay. But it's also been Yahoo. It's been Dropbox. It's been Google. There was a couple of weeks ago, Google, that some of the passwords that they were storing clear text for a limited time, whatever it was, but they were actually passwords that were clear text for a while from Google. So everyone is vulnerable to this. It's not something that we can say, yeah, there's no way that anyone's going to get access to our system through a username and password. And for each of these things, we can say that, right? We've got to be protecting against all of these things. So now let's assume that someone gets access to username and password. Now it's important that we have the ability to limit what they can do within the device, within our ecosystem, within our server, once they've gotten access through username and password. So for example, if all users have admin access, because these are physicians, they're going to be using our system responsibly. They're not going to be doing bad things. It will just save time if we just give everyone admin access, and then those guys won't use it. The problem is, as soon as one of those passwords is compromised, now suddenly the bad actor also has admin access to do whatever it is that you're doing with your device. And by the way, that's the other thing about the Internet of Things, is before, when I could get access to your computer, what could I do? I could sell you Viagra or something, or I could try to take you to sites that are going to make me money somehow. Or I could just sort of, from an evil standpoint, try to make your computer useless. That's about what I could do. Now with medical devices, I can stop your heart. With robots or factories, I can kill the guy near the machine by swinging this 2,000-pound weight at him, because as soon as I control the device, as soon as I get access to the device, I can do whatever the device does. So that device that's keeping me alive, suddenly I can turn it into a device that unkeeps me alive. So that's part of the Internet of Things, is with the Spider-Man thing, with great power comes great responsibility, whatever. It's really, really true with the Internet of Things. Now that we're able to do a thing, we're now also able to have someone else do that thing, and maybe do that thing in a bad way. All right. So one of the things I was really excited about in this conference is, as I'm talking to people were saying, yeah, I really wanted to go this week to learn XYZ, or I wanted to find out about this certain set of things, or which is just another way to say I wanted to learn things. So anybody here to learn things this week? Yes. All right. So I hate to have just these high-level talks about a bunch of things that maybe you can't actually do something with. So I like to, whenever I can, take one deep dive into, let's pick one thing and let's go learn about that one thing. So since securely hashed credentials is now flashing on the screen, let's talk about that. So this is the case where, like I mentioned earlier, MySpace, Yahoo, Dropbox, Ashley Madison, there's a billion other places that have had their, maybe not a billion, but a lot, that have had their password databases dumped on the open internet. Someone got in, was able to get access to that database and dump it on the internet. Well, now what happens? Thankfully, in most of the cases now, we're smart enough not to store your password in clear text. If your password was stored in clear text, now your password and everyone else's is dumped clear text on the open internet, and everyone has access to that password. That's really bad, because if you use that same password on different sites, people have access to it. If used even on the site that got hacked until they find out that they've been hacked and they shut it down and so on and so forth, they have access to that. So this is bad. We don't like this. So great. So we hash passwords, and we'll talk about what hashing is one second, but we protect them. And so now they dump these tables with the protected passwords. Okay, great. So we've kind of got this layer now. Now we're protecting the password with a hash. But now, and they dump them on the internet, but it's hashed. Well, now the next layer in the attacker's toolkit is called a rainbow table. And so my account manager at Geisel Software, her name is Katie Rainbow. She would just like you to all know that she is not in any way affiliated with the nefarious act of rainbow tables in hacking passwords. And also, she has no idea what that is. So rainbow tables are a way that we can take your hashed passwords and get access to what the actual passwords are. So let's go through this for a second and talk about how these work. All right, well, I'll just have to say words and you'll have to follow me, because I don't know which of these things makes it point. So this is an example of a password database. So the first guy's password is password. What's stored in the database is on the right side here. What's stored in the database is 3A6F2. That's the hash of his password. For right now, it doesn't matter how he came up with that, except that it's a one-way algorithm. So now the next password, J3PM, $, so on, gets hashed to something that looks very similar to the hash of password. It's just a bunch of digits. In reality, it's many more digits than this. This just fits on PowerPoint better. The next password, 12345, again, it gets hashed to something that doesn't really look like 12345, and so on. So we have this set. The key is I can always take the password on the left side and turn it into the hash on the right side. I cannot take the hash on the right side and turn it into the password on the left side. This is a one-way hashing algorithm. So some people will say, well, we encrypted the passwords. Don't encrypt the passwords, that's bad. Encryption can go, you can encrypt and you can decrypt. You don't want that. You want a one-way hashing algorithm. That means I can go one way and not the other. How does that work? Let's stick with this grade school thing. Remember second grade? Probably not. But in second grade, maybe, you learned how to do this long division thing. So say, what is 7 divided by 3? And the answer was 2, remainder 1. You guys remember the remainder thing? So, nobody remembers that one. So, you have this remainder. But if I told you the answer is 2, remainder 1, you couldn't tell me what numbers were divided. You could only tell me, for example, maybe the numbers were 6 and 13. 13 divided by 6, 2, remainder 1. So you can't tell me what that initial number was. This is roughly, if I just give you the remainder, this is roughly how password hashing works. Is now, they're using much bigger numbers, very, very fancy math, but this is effectively how it works. You can go one way, but with that data, you can't go back the other way. So now, let's look at what a rainbow table is doing. So a rainbow table is going to take this. Now, on the right side here, we have this, this list of passwords that we've created to make our rainbow table. In reality, we've made billions of these passwords. Unfortunately, we looked into it, and PowerPoint with billions of passwords, the font, very, very small. So we're going to use 4 for our demonstration here. On the left side is the hashes produced by those. So as a bad actor, I'll produce this table. I'll go through billions of passwords. And by the way, when I'm looking at billions of passwords, that does include your dog's name followed by a $, followed by the number of the date in your birthday. So passwords that are very, very strong are not going to be in there, but passwords that are at all weak are going to be in my rainbow table. So let's bring back, this is just the thing that got dumped on the internet. Say this is the Dropbox database, and this is the password hashes. So I have the first one, which is 3A6F2. So is that in my rainbow table? Yeah, it turns out it is. It's right here. And so for my rainbow table, I can use that to go backwards, and I figure out what the password is. Now, F374C, that was a really good password. They're like capital J, period, crazy thing. Is that in my list? No, it turns out that's not in my rainbow table. But that's okay, because I have so many other users in your database whose passwords I can go through. So the next one, 1, 2, 3, 4, 5, yeah, that turns out to be, and the last one was a pretty good password. So that one is not in my rainbow table. Perfect. So this is how rainbow tables work, is they're not trying to get every single password in the database. They're just trying to get a lot of them. And so a solution to this is, for example, there's an algorithm called bcrypt. And what bcrypt does is with every password in the database, I include what we call a salt. A salt is a crime, but a salt is just some randomness that I'm going to stick in with your password. So your password is terrible, it's password. I'm going to stick 37AXX2 after it, and then I'm going to hash that. And what that's going to do is it's going to create a different hash result at the end than your password would have created. And now it's not going to be in the rainbow table. So bcrypt, without going into gory detail, is storing this salt with the password, and it's putting a different salt for every password in the database into the database with your password. So what happens is, when I go to create a rainbow table, I would have to have the salt for each password. What it means is, I can only have a rainbow table of one password, because each password has a different salt. So it effectively defeats rainbow tables. So this is just one of those examples. Actually, bcrypt also has a cool thing in it that the more computation we add is the harder it is to break, and eventually we increase computing, and now we need to increase the complexity of our hashes, of our encryption, whatever, so that it's harder to break. Bcrypt has a thing built in so that part of the definition of it is to a power of 2, how many times I need to run this. So each time I just increment that number, and I've doubled the difficulty of breaking a bcrypt password. So there's some cool things built in. There's stuff in the world that is out there that you can use and deploy on your machines, on your systems, to make them more secure. This is just a little deep dive that I want to take into how rainbow tables actually work, what a hacker's actually doing when they're creating a rainbow table to hack you, and now the solution that we have to solve that and to fight against a particular attack out of many options. Does that make sense? Any quick questions on rainbow tables? All right, go ahead.
Can you actually re-engineer the algorithm from the rainbow tables if you have many matches? The hashing algorithm?
So it's a good question. So the rainbow table has to be built for a particular hashing algorithm. So I will build a rainbow table, say, for MD5 some, or I will build a rainbow table for this. What happens, though, is there's no real defense of which algorithm let me say it this way. There's no real defense of hiding which algorithm I've used, because if I can get into your server to dump the table, then I can probably also I have access to your code that's computing the algorithm, which I can just look at now, and I can create a rainbow table from the algorithm you used. Even if it was some custom thing you made up, I can still create it from that. And that's where something like bcrypt defeats that, because you include the salt. That was a great question. Okay, good. If there's any more, just you hold them till the end. But I want to make sure I didn't leave you guys in the lurch on anything, so that was a really great question. So one of the things, I had this crazy high school history teacher. That seemed to be where they put them, by the way. But yeah, somebody else had one of those too. But he had this thing on his wall that said, those who cannot remember the past are condemned to repeat it. And I think that really applies to technology. When we first started into these things, we were creating some new history. But at this point in time, there's history behind us. We understand how attacks are created, or we should, if we go back in history. And so one of the things I like to always do is look back in history and see how things happened, so that we can see how they're going to happen. And it turns out we can actually predict if we do that. And so I think one of the most, I've been probably the first one in all of your minds, if we think like, when do we really start thinking about cybersecurity, was in the time of the Vikings. I mean, I assume that's where everybody else went with this also. Immediately go back to the time of the Vikings. So Vikings, it's interesting actually how we developed the sword back many moons ago. They used to be square at the end, because I would hit you this way with a sword. I would sort of whack you with the sword, like a slightly sharpened hammer or something. And so then we created shields to defend against that. So when you whack me with it, I do that. Or the other thing we created was chainmail. So we created chainmail, which is metal loops, right, that kind of protect me, so that when you go to whack me with the thing, it kind of brushes off of me rather than the blade digging into me. So we had this great invention, chainmail. We found a defense for the sword. And then somebody went, well, wait, you have a bunch of holes in that. What if I just sharpen the end of my sword and I make it pointy, and then I'll poke you with it? And then we didn't like being poked, and then we came up with shields. And so the point is that what we did was we went back and forth. As a new innovation came out, we came out with a new way to exploit that innovation. And then a new innovation came out, and then we came out with a new way to exploit that innovation. And it's very much where we are in the Internet of Things today, is every new thing that comes out, there's a new way to exploit it. So, all right, we'll fast forward quickly to the 1960s-ish, when phone phreaking came out. How many know what phone phreaking is? Okay, all right, fair, that's about half. So, the phone network at one point was new. Now, none of us have landlines at home. We try to teach our children about what a telephone is, and they look at us weird. But at one point, the telephone was new. And when the telephone was new, there was a company, AT&T, hereby represented by Andre the Giant, which was this huge, huge company. So big, in fact, we decided eventually we had to split them up as a monopoly. But they created things in this telephone network and decided, we'll charge you to call grandma who lives far away. We'll charge you for long distance calls. and they set up this network, and then we'll just charge you, we'll make all this money off of this infrastructure. Really, it was maybe the first sort of modern network where we're able to connect with each other in different ways. And it wasn't long before people found a way to connect computers onto this network and were able to dial into each other, right? But AT&T had set up this network, and on the network was a way for their computers to communicate to each other to say, this person is calling this person, I need you to charge this amount for this kind of a long distance call. And so they had this whole thing set up with awesome security, right? Please tell me you're getting the hang of this talk now. Not so much. So the security network was defeated by a whistle found in Captain Crunch cereal. This is the actual whistle, and hopefully it doesn't freak out my mic. Freak, see what I did there? So this is a 2600 hertz tone. And it turns out AT&T hadn't heard of Captain Crunch when they came up with their security methodology. Because making that tone gave you access to their network. And so what people would do was they would figure out, obviously, what the tones were that AT&T was making. They would repeat that same set of tones, and then they would have full access to the long-distance network, making free calls. And so you couldn't do a lot of injury by doing this, but AT&T wasn't very happy about it, as you can see by under the giant's face. And so this keeps happening. Every time we develop a new technology, the telephone was a great one. Suddenly you could call around the world, right? How long before that did it take you? The best you had was telegraph. Before telegraph, the best you had was someone getting a letter halfway around the world, which turns out it takes a while to do. Now suddenly with the phone network, within seconds, you could be communicating with somebody around the world. That was an amazing innovation. But shortly after that amazing innovation was this amazing hack to take advantage of that innovation. So this keeps going on as we make advancements. Then there's a counter side to that. And so I want to sort of challenge you to that same lesson from history, from your IoT devices, whether it's you're building them, you're using them, what have you, about how this works. So now I want to step into ancient history, the times of Windows XP. And so Windows XP now no longer supported by Microsoft. They're not putting out any patches ever again, ever again, amen, for Windows XP until last week, or a couple weeks ago, when there was a wormable exploit found for Windows XP. And there were found 950,000 Windows XP on the internet vulnerable to this wormable exploit, which wormable means I'm able to get access to the machine and get enough control to the machine to be able to use that machine to infect other machines. And so now all of a sudden Microsoft is putting out a patch for Windows XP because this is such a major issue, and they're scrambling to try to get this solved. By the way, I don't blame anybody for these kinds of things. They're things that happen. We want to do what we can to mitigate them. We want to do what we can to fix them. We want to layer so that we can solve as many of these up front as possible. But they sometimes happen. For our IoT devices, what can we learn from this, even long after we want to stop supporting them? If, as a company, hopefully we've achieved success, then those devices are out in the field. And even if that device we decide no longer to support, if that device is suddenly part of an attack, we're going to have to do something about that attack. And we can't if we don't have any way to solve what's in those devices, to fix those devices. So, hence, firmware updates, which I always think, if you had a genie in a bottle, the first thing you would wish for is more wishes. I don't know who didn't think of that when they thought of the whole genie bottle thing. But that's the first thing why don't I just wish for more wishes? Now I have infinite wishes and your 3 thing is out the window. Well, we can do that with firmware updates now, because whatever it is that you put out in an over-the-air update, I can fix later. So I now have the ability, if I put the ability into my device to do firmware updates, I now have the ability to fix things that happen on the device. And this is like wishing for more wishes. We're able to go back and solve problems that we didn't know we had, that now have been made available after the fact. And as we're putting devices out, even if our code is perfect, which I'm sure everyone's is, then we're relying on libraries. And those libraries, an exploit is found in those libraries. We've got to be able to go back and solve that exploit. So some of the things with OTA updates that we do need to be careful of is, like I mentioned before, that man-in-the-middle attack. I don't know why I'm the man in the middle. I should be one of the good guys in this scenario. But there's the server, there's the device. We want to make sure no one else can update firmware to our device. So that's a little bit about what we talked about before with signing and making sure that the device only accepts updates from the server. The deployment in stages. Anybody a gamer? PlayStation, Xbox, PC? Okay. So, when something new comes out for one of those consoles, there's a whole talk on the world about who's getting it, because it doesn't come out all at once, right? They deploy it to some limited set of users first, and then it might get deployed to a few time zones. And what they're doing is, if perchance their testing wasn't perfect, and it bricks the PlayStation when they put it out, then they only want to brick a few of them. They want to stop and fix the update before they continue. And so one of the things in your OTA update deployment you want to think about is deploying in stages. There was a big issue with the Nest thermostat a couple of years ago. I called it the Internet of freezing to death, because the Nest thermostat put out update that would cause the Nest to draw battery too fast. And in about 2 weeks, it would lose battery and just die. And you'd have to you'd have to plug it in, charge it, and then hopefully get the new update from Nest that fixed it. But if it was in a house that you didn't have access for or whatever, and it was cold, this obviously could be a problem if your heater is no longer running because your device got a firmware update right? So this is the kind of thing, and again, we can look back. It's way easier to look back, and hindsight is 20/20. I'm not blaming them, saying they should have deployed it in stages, but I'll say, now that we see it, let's make sure that we do it this time and deploy it in stages and give it long enough that we may be able to see some of those things. But then also by providing OTA updates, we give ourselves the ability not just to correct security vulnerabilities, but also to add features. And in some contexts, depending on what the device is, this might mean changing the way that things are actually working in your factory and improving the cost return on the device, or improving the failure rate on the device. It may be improving a feature that you can actually charge users for. It might be part of your revenue model for your company. And then obviously we can fix security flaws with it as well. And so without the ability to update over the air, OTA updates or firmware updates, then we have no ability to get back out to that devices and fix the things I'm talking about. In hindsight, we can look back and go, oh yeah, that was a problem. With OTA updates, we can go back in time and fix those problems now that they've come out at least. And so this is one of those pieces. Again, there are a lot of pieces to the entire security puzzle. This is one of those pieces that allows us to fix the other pieces after we've gone out and haven't realized that there were any issues there. So now this is maybe my favorite part, is time to take questions. So I'm happy if we have some time to take some questions, but thank you. So I see a mic over here. Is that how we do questions, or just shout it out? Great. Questions? Go ahead, all the way in the back. Yeah. Okay, so the question is, it isn't the first step really to solve the things that we've already run into in the past and, have common standards across the industry that we can rely on and solve some of those things? And are there those standards in the Internet of Things that can solve some of those things? So the answer to your question is it depends. So it really does. It depends on the device. So one of the issues that makes the IoT unique in this case is that the devices are doing things that are so different. So, for example, one of the things you mentioned was, websites now all have gone to HTTPS. And so we should have our website on HTTPS. It's encrypted along the wire. And we've got this standard that all websites, no matter how different your website is, should do, and we use that. The problem in the Internet of Things is to something like HTTPS, we might talk about a device that's got such low battery power that it can't do that level of encryption. Or we might talk about a device that's using, say, a LoRa radio, where I can transmit 32 bits of data at a time, where I might not even have enough data to identify myself, let alone to do any sort of encryption in what I'm sending. And so, yes, we're seeing more and more things come for across the whole IoT spectrum. And as we're seeing hardware manufacturers who are starting to think of this more. So even the very small chips that are running on very low power are starting to include encryption services as part of the hardware so that you don't waste so much energy doing those things in software. So we're seeing those kinds of things, not that solves all of the things as you were asking about in your question, but it's some of those things that we're looking for other ways to solve or to solve in more devices. But the problem is still much of the variance of the devices, of the capabilities of the devices, of what they're solving and what they're doing. Yeah, and encryption is just a good use case of a standard, but the answer is sort of the same from the device. And don't feel bad if you need to get to the next talk. I'm happy to answer questions for as long as we have, but if you need to get to the next talk, go for it. But the issue around standards is the same thing as how do you set a standard that applies to the device that we didn't come up with tomorrow. So yes, there are more standards coming up for devices that sort of fit into a little bit better of a category. And the bigger the space gets, the more we can sort of define the categories and have a little bit of standardization around those things. And really, they're starting to use some of the standards that are there for other things, networks and IT infrastructure that we have in general. But yeah, it still is largely a problem of the variance of devices too. Okay, no problem. Yeah, so I'm happy to be in the back here, and if anybody has direct questions or whatever, I'm happy to answer them. So thanks again, everyone.